Hi students, good morning. The next topic is tautology and contradiction. First you should know the definition of tautology and contradiction. Tautology means a compound proposition is said to be tautology if it is true for all combinations of the truth values of its components. If we consider any combination of truth values of the simple propositions that is true, then it is said to be a tautology. Okay, it is true for all combinations of truth values, then the compound proposition is said to be a tautology. Similarly, contradiction means here false. Okay, the truth value is false for all the combinations of the truth values. Okay, then the compound proposition is said to be contradiction. If for all combinations of truth values, all the values are true means that is tautology, all the values are false means that is contradiction. Okay, let us consider the examples. Example 7, show that the proposition P implies Q double implies negation P or Q is a tautology. Okay, for that consider a truth table for all combinations of a truth values. Okay, see here P and Q, only two simple propositions P and Q. P truth values are true true, false false, true false, true false. See, first one is P implies Q. P implies Q. P implies Q is false only when first one is true, second one is false, remaining is true. So here true, false, true, true. Okay, next consider second one, negation P or Q. For that, first find out the negation P. Negation P is here true, false, true, false, false, true, false, true. Okay, next negation P or Q. R statement means what? If both the values are false, then only it is false. See, consider negation P and R. Sorry, negation P, Q. Okay, false, true, true. False, false, false. True, true, true. True, false, true. Okay, if both the values are false, then only it is false. Remaining three cases it is true. Next one, see here, already we find out P implies Q and negation P or Q. P implies Q is considered as A. Negation P or Q is considered as B. Okay, now we have to find out A double implies B. Okay, see this is A, this is B. A double implies P means P implies Q, double implies negation P or Q. Okay, see double implies means what? If both the values are true, then only it is true, or if both the values are false, then only it is false. Okay, if both are different, then only it is false. So here A true, true, true. False, false, true. True, true, true. True, true, true. If both the values are same, then it is true. Otherwise, it is false. See, now you will get all TT means all the values are true for all combinations of truth values. Therefore, the given compound proposition is a tautology. Okay, this is a tautology. Similarly, consider second example. Example 8. Show that the proposition P and Q and negation of P or Q is a contradiction. Here, first we have to find out P and Q. Next, negation of P or Q. Okay, first find out P and Q. And statement is true when both the statements are true. See here, true, true, true. True, false, false. False, true, false. False, false, false. Okay, next, see, inside the bracket P or Q. P or Q means if both the statements are false, then only it is false. See here, true, 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 false. Next, negation of P or Q. See, this is a P or Q. Negation means here true, false, true, false, true, false, false, true. This is negation of P or Q. See, next, this is considered as A, this is considered as B. P and Q. It is A, and we have to find out A and B. Okay. See here, this is A, this is B. True, false, false. False, false, false. False, false, false. False, true, false. Okay. So here all the truth values are false. Therefore, the given compound proposition is a contradiction. Okay. Next, consider example 10. Example 10. Prove that P and R double implies PRQ and PRR is a tautology. See, first P and R. Sorry, in the question wrong. That is P and Q and R. P, R, Q and R. We have to find out P, R, Q and R. Okay, first find out Q and R. This is Q and R. See, this is a truth values for P, Q, R. See, first for P, 40 for false. Here true, false, 2, 2. Okay. In case of R, true, false, like that. Okay. First find out Q and R. Okay. See, consider second and third column. True, false, true, false. Like that you can find out Q and R. Okay. Next, P, R, Q and R. Make this correction. Okay, that is Q, not P. Then you will get, see, consider P, first one and fourth one. First one and fourth one, R symbol. Okay. True, false, true. If any one of the statement is true, that is true. If both are false, then only it is false. Okay. See, first one is over. Consider this as A. Okay. Next, see, consider RHS side PRQ. First find out PRQ. Next find out PRR. Okay. Next, consider this as X and this is Y. These two are connected by AND. Okay, like that you have to find out. Finally, B. B means X and Y. See, these two, X and Y. Next, last one, see, totally this is considered as A. This is considered as B. Here we have to find out A double implies B. Okay. A double implies B means we have to consider this column, A column and B column double implies. Double implies means true, false, true. Remaining two cases it is false. Okay. True. Like that you will get all true. Therefore it is a tautology. Okay. Similarly, example 11. Okay. Try yourself. Next concept is logical equivalence. Okay. Logical equivalence means if we consider two compound propositions P and Q. Okay. These two are logically equal means the truth values of both P and Q are same. Okay. See, suppose the truth value of P is true, truth value of Q is also true. Then only we can say P and Q are logically equal. So it can be denoted like this. 3 lines. P is logically equivalent to Q. We can read it as P is logically equivalent to Q. See here, definition. Two compound propositions P and Q involving the same components are said to be logically equivalent if truth values are the same for each different combinations of the truth values. You have to get same truth values for all the combinations of truth values. Then only we call it as both are logical equivalent. We can write it as like this, P logically equivalent to Q. Okay. See, some of the logically equivalent propositions are there. We can call it as laws. First one is idempotent law. Idempotent law. See, first one P R Q. logically idempotent. Idem means same. P or P is logically equivalent to P. P and P is logically equivalent to P. Suppose consider Q. Q or Q is logically equivalent to Q. This is called it as idempotent law. Next one, law of double negation. Double, see, suppose consider negation B. If you consider 2 times, you will get same. This is called as law of double negation. Negation of negation P equal to P. Negation of negation P is logically equivalent to P. Suppose negation of negation Q, which is logically equivalent to Q. This is called as law of double negation. Okay. Next one, third one, commutative law. Already you studied in case of complex numbers, real numbers, like that only. Commutative laws, 2 laws. First, P or Q is logically equivalent to Q or P. This is commutative law. Next, P and Q is logically equivalent to Q and P. See, these two are commutative laws. Similarly, associative law. You familiar with these laws? Commutative law, associative law, distributive law. Okay, associative law. See here, first in case of R, P or Q or R is logically equivalent to P or Q or R. Okay, similarly in case of AND, P and Q and R is logically equivalent to P and Q and R. These two are associative law. Next one, distributive law. Distributive law already studied in case of real numbers. This also. See here, P or Q and R is logically equivalent to P or Q and P or R. See, this is distributive law. Similarly, P and Q or R, it is logically equivalent to P and Q. In center you will get R. Again P and R. These two are distributive laws. Okay. Next one, De Morgan's law. Very, very important. See here, negation of P and Q is logically equivalent to negation P or negation Q. See here, negation of P and Q, but it here R. Okay, ulta. Here N means RHS R. Okay, negation of P and Q is negation P or negation Q. Similarly, negation of P or Q, okay, logically equivalent to negation P and negation Q, reverse, and R. Okay, next one, these two are De Morgan's laws. See, next, seventh one, negation of P implies Q. Negation of P implies Q is logically equivalent to P and negation Q. Negation of P implies Q logically equal to P and negation Q. Next, last one, negation of P double implies Q is logically equal to P and negation Q. Here R, Q and negation P. Okay, you have to remember all these laws in order to do the problems. Okay, next, example 12. Show that first one, negation of P and Q is logically equivalent to negation P or negation Q. Okay, see, this is De Morgan's law. We have to prove the De Morgan's law. See here, negation of P and Q is logically equivalent to negation P or negation Q. Okay, by using truth table we have to prove that. Okay, find out LHS and RHS separately, and we have to show that LHS equal to RHS. Okay, see here only two statements, P and Q. Okay, 4 possible combinations. First, find out inside the bracket P and Q. P and Q is true, false, false, false. Next, negation P and Q. Negation P and Q means negation of third column. true becomes false, false become true, false true, false true. Okay, consider this as fourth column. Okay, here we are mentioning column numbers. Okay, this is LHS. Next, negation P and negation Q. First find out negation P. Negation P is true, false, false, true, true. Negation Q is false, true, false, true. Okay, these two are connected by the symbol R. We have to find out negation P or negation Q. Negation P or negation Q. False, 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 true, 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 false, true, 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 true. Okay, now observe fourth column and seventh column. Both are same. Therefore, fourth column is logically equivalent to seventh column. Both are identical. Therefore, negation P and Q is logically equivalent to negation P or negation Q. Similarly, find out for second one. We have to prove that second one. Okay. Next, example 13. Example 13. Prove negation P implies Q logically equivalent to P and negation Q. These are very important problems. Okay. First find out P implies Q. P implies Q means it is false only one case, true, false. Okay. Remaining three cases it is true. Next, negation of third column. False, true, false, false. Okay. LHS is over. Next, P and negation Q. This is first column is P, negation Q. Find out negation Q. Negation Q is false, true, false, true. Okay. P and negation Q. First column and fifth column. Unstatement. Okay. True, false, false. True, true, true. False, false, false. False, true, false. Okay. Now observe fourth column and sixth column. Both are identical. Therefore, negation P implies Q is logically equivalent to P and negation Q. Okay. Next, example 14. See, this is also law. We have to prove that P implies Q and R logically equivalent to P implies Q and P implies R. Okay. First P, Q, R. Here 3 statements are there. Therefore, 8 possible combinations. Okay. Here first we have to find out Q and R. Next P implies Q and R. First statement and fourth statement. Okay. That will become fifth statement. Consider this as LHS part. Again we have to find out P implies Q, P implies R. Okay. Next, P implies Q and P implies R. Now observe the fifth column and eighth column. Okay. Both are identical. Therefore, P implies Q and R logically equivalent to P and Q and P implies R. Okay. Thank you, students.